Good afternoon, fifth period. How you doing? How you doing? We are recording. We're going to continue our lecture from yesterday. So the lecture title doesn't change. We're still talking about linear functions. We're still talking about slope and equations. But this is part 2, the sequel, which might be more interesting than the first movie. I don't know. How do sequels usually go? The sequel is always worse. The sequel's always worse. Well, hopefully this one isn't worse. Let's start off today by giving you the answers to the do now questions. And this is so that way you can take a moment and review what you did. And if you got the same as what I'm about to put up here, awesome. If you didn't, go back and double check your steps. You should have written out all your steps so you can make sure that it's in the right spot. So for the first bullet point, you should have gotten a slope of 2. For the second bullet point, we should have gotten a point slope form of y minus 6 equals 2 times x minus 12. And for the third bullet point, you should have gotten y equals 2x minus 18. Okay? So during the lecture, refer back to your do now, your work. Check to see if your numbers are different, where you may have gotten off. And when I'm done with the lecture, we should have about 10 minutes left in class. You can come up and ask me for help if you're still confused as to why your numbers are different from mine. Okay? So I'd like you guys to go back into your notes from yesterday. Hopefully those are still out on your desks from where you used them earlier. And I'd like someone to please find and read for me in a very loud, strong voice, standard form of the equation of a line. Go.
Where's it at? I'll read it, but I don't have it. I was reading yesterday.
Okay. It is in the notes from yesterday. Should be about middle of the page on the far right-hand side.
Ax plus by equals c.
Yep. We got 2 people, 3 people finding it all at once. Nicely done. What was interesting about A, B, and C from yesterday?
They're whole numbers.
They're whole numbers. Now, if you notice on my paper, I kind of don't have enough room to really write whole numbers without writing it super tiny and weird. So I'm going to give you the mathematics symbol for whole numbers. I do hear some side music. If that's yours, please turn it off. I appreciate it. Thank you. Thank you. It's gone. Thank you very much. That's a letter Z with the kind of diagonal bar with there being 2 lines in there. So it kind of looks bolded and big. And that symbol means whole numbers, integers. Okay? So if that's something interesting for you, put an exclamation mark by it. Come over here to the left hand and put your exclamation mark again and write down what that letter Z means. It means whole numbers. Okay. You didn't see it, but I did write it off to the side. All right. Come back with me over here to the left-hand side real quick. Now you can see it. And I'd like you to title this section, Converting from slope-intercept to standard. That's what we're going to work on today. We've done our justification bars because we're in geometry instead of algebra. So we do all the same stuff, but instead of just writing all these weird symbols and magically changing things, we talk about the reason. And so I have my rationale bar, my reason bar, but I'm going to add something to this just to make it a little more in-depth. The workspace, I'm going to call statements. And the right-hand space that tells me why I do stuff, I'm going to name reason. reasons. Okay? So this is your 2-column statement reason format. Here we go. So I'm going to start with the slope-intercept form from the do now. And the reason I'm writing it is because it was given to me. And it's the slope-intercept form. You'll get to see this again in a second, but I'm going to zoom in kind of close to the standard form. Okay, there it's in the middle of the screen for you. Can you describe this equation for me, what it looks like? When you look at it, where are X and Y positioned? Same side? Different sides? Different sides on this one? From each other? In relation to each other. Are they on the same side as each other or on different sides from each other?
Same side.
Same side. And we're talking about the sides being in relation to this kind of equals bar right here. Yeah? So they're both on one side of the equal sign. They're both on the same side. So what this says is that when we're all said and done with this equation, when we're done converting it, and we have it in standard form, our x's and our y's should be on the same side of the equal sign. And this letter C is representing what kind of number? Yeah, what kind of number is this letter C representing? Yeah, and she responded with a whole number, which is exactly what you were thinking. Yeah. And you didn't know the question, you already knew the right answer. You were so smart. All right, so we want to get our thing to look like that standard form right there. So what's the first thing I should do to get X and Y on the same side of the equal sign as each other?
Minus 2x.
Minus 2x. All right, want to subtract 2x. What's the name of that property that allows me to do that? What is it called?
Subtraction.
Beautiful. It's the subtraction property. When I'm done, I'm going to have something that looks like that. Does that look like standard form?
No.
Is X and Y on the same side of the equal sign as each other? Are X and Y both on the same side? Sure. Do I have any fractions or decimals?
No.
Then you know what? It's in standard form. Because that's all the standard form says. It doesn't say anything about the sign of these numbers. It just says X and Y have to be on the same side, and all the numbers you see had better be whole numbers. So we're done, technically. But have you written a paper in English and like you get it back and it's covered with all these red marks and the teacher's like circled letters and been like, yeah, it has to be capitalized and the comma's in the wrong place and you didn't put a period and you're just imagining her grading this at night going, cap letter, comma, and you picture her twitching like this? Was I the only one who pictured their English teacher grading that way? You probably, I have an overactive imagination. That's what I pictured my English teacher doing, grading my paper, because it was more red than paper when I always got them back. It was terrible. So what happens is in the math teacher's brain, in the mathematician's brain, is when they see this equations kind of thing starting with a negative sign, most of them go, and start to twitch. So we got to find a way to get this first number negative without changing the rest of the sentence. How could we do that? Change the signs. How? What do we do to change the signs? Multiply by what?
6, 8,
6?
8.
What could we multiply by that would change the sign of everything but not change any number?
Positive?
Negative
divided by negative. That'll totally change the sign of things.
Oh,
Awesome.
say I hate you.
I'm smarter than you.
Oh,
Don't be hating.
don't want shoot at you.
Don't be hating. So you're going to multiply by a negative. But negative what? Negative 6? Negative 2? Negative 8? What number can we multiply by and not
-1.
change the number?
-1.
There you go.
That was close.
You really were. You really were. With the 8, it was so close. So you're going to multiply by the -1. I have something that kind of looks like distribution now, don't it? Yeah. So pretend it's distribution and just multiply that way, the way you would for distribution. So what you had said at the beginning, just change the sign of everything. You're right. But this is what you're doing to make that change the sign of everything happen. Okay? You have your justification. And now you've got it written down in a way that won't make most mathematicians go, ugh, the negative's in front. Okay? It's written pretty. Is all. Awesome. So really easy when everything are whole numbers already. But in the example that we did yesterday, when y'all gave me the numbers to work with, we ended up with really weird fractions, didn't we? Yeah, flip back to your notes from yesterday. Didn't we end up with some weird fractions?
Yes.
Yeah. So you know what? Let's talk about how we do this same process when there's fractions. So set up for me your statement reasons bar again. Set up your statements and reasons bar again, or table rather. Statements and reasons table. And then someone who has their notes from yesterday, can you please read the slope-intercept form of the line that we had yesterday, that we left off with? Go ahead.
That one?
That is the slope-intercept form of the line, yes, and I wasn't specific, so thank you. I'm looking for the equation that we generated that was in that slope-intercept y equals ms plus b4.
Y equals 17 over 7.
Something over 7x, what?
17 over 7
17 over 7x
minus 22 over 7.
22 over 7. Should be at the very bottom of the page, the very last equation.
I found it.
Okay, and this is what was given from yesterday. And again, it's in slope-intercept form. Okay, and on the next step, I'm going to write these fractions a little bigger because I'm having issues with it written that small. All right. So at this point, you have a choice to make. Do you want to get rid of the fractions right off the bat, like the first thing you do, just get rid of them so you don't have to deal with them? Or do you want to maneuver it around, make it look like standard form with a bunch of fractions, and then go through and get rid of the fractions? Get rid of the fractions first? All right, I'm so down with that. Come over with me to the left-hand side of the page, and I want you to get your red pen if you're using different colors, please, and mark down the start because this is important, yeah. Here's what's important. To get rid of, I got you covered, hon. To get rid of fractions in an equation, and I'm going to write the word equation in all caps because it's super important for me to make you realize that you can only do this in an equation. If you've got just fractions hanging out doing like fractiony things on their own, you can't get rid of them. Okay? But if they're an equation, you can totally get rid of them, and this is how you do it. You multiply the entire equation by the common denominator. Now in a fraction, is the denominator the top number or the bottom number? The bottom number, yeah, you're right. Now notice the use of the phrase common denominator, and here you've got two fractions, which works out, and their denominator is the same, so we don't have to think hard. But I wanted to write it this way because you're eventually going to see equations that have a bunch of fractions in them, and none of the denominators are the same. Algebra 2. Excuse me. Okay, calculus, yeah. All right, you could see them before you're done with whatever schooling you're going to do. And I want you to know that this important sentence right here can go with you to every other math class that you have to deal with. And whenever you run into an equation that has some fractions in it, you can totally do this and get rid of those fractions. All right? Okay. So that's what we're going to do. We're going to multiply the entire equation by the common denominator. What's the common denominator in this equation? 7. So I'm going to multiply the entire equation by 7. And I'm taking a bit more space here to write it, just so that way it's easier to see the fraction. If you want to write it tiny and do it all on one line, that's okay too. I'm just trying to make it a little easier for you guys to read. And what's the reason I'm multiplying the whole equation by 7? Awesome. So the reason is getting rid of the fractions. Because we don't like them at the party. Unless you're talking about fractions of pizza, cake. And now you want dessert. You're welcome. Looks just like distribution again. So then the reason is, say it, distribution. You're right. Distribution. All right, let's do it. Give me a quick show of thumbs. You're not really certain where the 17x or the 22 came from. If you're not sure, give me a quick thumb up. I just want to see. Okay. Not very many. Awesome. Lovely. This afternoon after school, I'm going to cut a video that shows where this comes from and working with fractions in a bit more depth. You're welcome to join the studio audience. It'll be formatted just like this. And then I'll get that posted to YouTube so that you can review it. So if you're able to, stay after school a little bit today and sit in on that broadcast. That would be awesome. Okay, so I'll do it then. All right? And if not, you can catch it on my YouTube channel, so don't feel like you're going to miss anything. All right. This thing totally looks like this one up here, doesn't it?
No.
Well, okay, so yeah, no, the only difference is that there's a number in front of the Y on the bottom one where there isn't on the top one, right? But other than that, they pretty much look identical, don't they? I mean, yeah, the numbers are changed, but the form is pretty much the same, right? So guess what? The steps you take to go from here to the standard form? Exactly the same. All right, so I'm going to write down the algebra stuff. I'm not going to write down the reasons for you anymore on this one. Y'all need to write the reason. I'll ask them. Y'all respond and write them down. For your binder check, you have to have all the reasons written, even though I'm not going to fill it out and you're not going to see them on my notes. All right? So from here, I'm going to move the x over. What property allows me to move that x over? What property was it? There you go. Make sure you write it under the reasons, because I'm not going to write it for you. All right, what am I doing now?
Multiplying
By?
-1
Beautiful. Why am I doing it?
to change the sign.
Gorgeous. Make sure that gets down in your reasons.
What?
Because we're trying to change the sign of everything in the equation. We're done. That's it.